Hello everyone and welcome to another Math tutorial video. Now I'll be discussing Form 4 Additional Mathematics, Chapter 7 Coordinate Geometry, HOTS question example 5. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, let me read the question now. The following diagram shows a kite. The diagonal AC bisects the diagonal BD at a point M such that angle CMB is equals to 90 degrees. So as you can see here, this is the angle CMB. Find the equation of the straight line AC, the value of P, the coordinates of point C such that ratio of AM is to MC equals to 1 is to 2, the equation of the locus of the moving point Q such that its distances from the points B and D are in the ratio 3 is to 2. So I hope that you will attempt this question in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solution. So without further delay, let us start to solve the question. Before we begin to solve this question, it is better for you guys to know the properties of a kite. So let me show you the diagram of the kite now. Okay, so as you can see here, this is the diagram of a kite. Okay, let me explain to you the properties of a kite. So as you can see here, the three lines here are totally different. So that is why it distinct in the 1 line, 2 line and 3 lines respectively. So as you can see here, straight line BC is equals to straight line CD. Okay, and straight line AB is equals to straight line AD. Okay, so from here, as you can see here, this point O is act as a midpoint for the straight line BD. So in this case, we know that straight line BO is actually equal to the straight line OD. Okay, and most important thing, as you can see here, straight line BD is actually perpendicular to the straight line CA. So that is why you have the 90-degree angle symbol over here, guys. Okay, so this is the short explanation regarding the kite properties. So I hope that this explanation will help you in order to solve this question. So let me delete this picture. Okay, so from here, let us begin our discussion for the question part A, where we require to find the equation of the straight line AC. So as you can see here, this is the coordinate of the A, but then we don't know the Y coordinate value, but we do know that the coordinate A is actually representing the Y intercept. Okay, and the second thing is we do know the gradient of the straight line AC. However, we do know that the straight line AC and straight line DB are perpendicular to each other. So the first step on what we need to do is we need to find the gradient of the straight line DB. Okay, that will be our first step, guys. Okay, let us proceed to our working. So from here, we find the gradient of the straight line DB. So from here, MDB will be equals to y2 minus y1 divided with x2 minus x1. So from here, we set our point 1 as B and point 2 as D. So from here, y2 minus y1 will be 7 minus 1. Okay, and then divide with x2 minus x1 will be 2 minus 4. Okay, let me underline the fraction. Okay, and close the bracket. Okay, you calculate this, you should get your gradient of the straight line DB is equals to -3. So this is our first step. So let me underline the solution for the straight line DB. I mean the gradient of the straight line DB. Okay, so once we get the gradient of the straight line DB, now we can use this value in order to calculate the gradient of the straight line AC. Okay, how are we going to do that? By using the perpendicular formula, guys. Okay, which in this case, M1 you times with M2 equals to -1. So this is the formula that we're going to apply over here. Okay, let me box this. Okay, in this case, our M1 will be representing as gradient of the straight line AC. Okay, and then our M2 will represent as gradient of the straight line dB, which you have already find in the first step. Okay, which in this case is -3. Okay, and then you should get equals to -1. Okay, so from here, to get the gradient of the straight line AC, what you need to do, -1 you divide with -3. So you calculate this, you should get the gradient of the straight line AC is equals to 1/3. So this will be your second step. Okay, so let me underline this. Okay, so once we get the gradient of the straight line AC, the next step on what we need to do is we need to find the coordinate of M. Then you can ask me, why don't we use the point A in order to calculate the equation of the straight line AC? Okay, the explanation is very simple. The point A is actually incomplete, guys. Okay, the P variable here is unknown, but we do know that the point A is actually a y-intercept. So we need to find another alternative. So in this case, we only can find the point M by calculating the midpoint of the straight line dB. Okay, as I mentioned in the earlier explanation during the properties of the kite. So okay, let me continue to the third step by finding the coordinate M. Okay, so to find the coordinate M, you use the midpoint formula. Okay, so from here we start with the x coordinate, 2 plus 4. You divide with 2. Okay, similar concept for the y coordinate, 7 plus 1. Okay, you divide with 2. You calculate this, you should get your coordinate M is equals to 3, 4. Okay, so this will be your third step. Okay, let me underline this. Okay, now we already have a gradient of the straight line AC and a point. In this case, the coordinate of point M. Okay, these two information is sufficient for us in order to come up with the equation of the straight line AC. Okay, now our final step is to come up with the equation of the straight line AC. So from here, let us write down in the working here. So from here, straight line equation AC. So we're going to use the formula y minus y1 equals to m in a bracket x minus x1 close bracket. So we're going to substitute the coordinate m and the gradient of the straight line AC into the equation here. So from here, y minus 4 equals to 1/3, okay, in a bracket x minus 3 close bracket. So from here you calculate this, you expand the bracket. So from here you should get y minus 4 equals to 1/3x minus 1. Okay, so from here you should get your final answer, y is equals to 1/3x plus with 3. Okay, so this is your final answer, guys. So from here we have already successfully come up with the equation of the straight line AC. So let me underline the solution for the question part A. Okay, so from here let us proceed our discussion for the question part B, where we need to require to find the value of P. Okay, so as you can see here, this value of P is located into the y coordinate of A, point A, guys, y coordinate of point A. So since we have already come up with the equation of the straight line AC, so in order to find the P value, we just need to find the y-intercept. Okay, so from here the working will be very simple, guys. Okay, so to calculate the y-intercept of AC, y-intercept of AC, so you set your x equals to 0. So from here, when x equals to 0, So from here you should get your y equals to 1 over 3 times with 0 plus with 3. So from here you get your y equals to 3. Okay, since in this case your y equals to 3 can be compared with p value over here as the y-intercept. So from here you should get your final answer, p is equals to 3. Okay, this is based on the comparison, guys. Comparison. Okay, let me underline the solution for the question part B. Okay, so from here let us continue our discussion for the question part C, where we need to find the coordinates of point C such that ratio of AM is to MC is equals to 1:2. Okay, so from here, so what we're going to do is we're going to sketch the straight line of point A, point M and point C. So please wait, guys. Okay, so this is the complete sketch of the straight line AMC over here, which is divided into the line segment ratio of 1:2. So from here we know the coordinate A and coordinate M, but we don't know the coordinate C. So from here we let our coordinate C as x, y. Okay, so from here let us continue our working. So from here, to calculate the coordinate C, we're going to use the line segment formula in reference to the coordinate M over here. So from here, let us calculate the coordinate C using the line segment formula. Okay, let us start with the x coordinate. So from here, 0 times with the opposite ratio 2. Okay, and then plus with x times with the opposite ratio 1. Okay, and then divide with the summation of ratio, in this case 1 plus 2, which is equals to 3. Okay, you calculate this, you should get your x coordinate is equals to 3 over here. Okay, so this is for the x coordinate. Let me underline the fraction. Okay, similar step to the y coordinate. So the 3 you times with the opposite ratio 2. Okay, plus with y times with the opposite ratio 1. Okay, and you divide with the summation of ratio, in this case is 3. Okay, you calculate this, you should get equals to 4. Okay, let me underline the fraction and close the bracket. Okay, let us solve this simultaneously for x and y coordinate. So from here, 0 plus with x, because 0 times with 2 you get is 0, so x times with 1 you get is x. So these 3 at the denominator you're going to times with 3 over here, so you should get equals to 9. Okay, whereas for the y coordinate, so 3 times with 2 you get is 6. Okay, y times with 1 you get is y. So from here, the denominator 3 you times with 4 over here, you should get equals to 12. Okay, so from here you calculate, you should get your x equals to 9 and y equals to 6. So this 6 from the left hand side you move it over to the right hand side, so it will become negative 6. So 12 minus 6 you get your y equals to 6. Okay, so from here we know that our coordinate C will be equals to 9, 6. So this is your answer for the question part C. Okay, let me underline the solution for the question part C. Okay, so from here, let us proceed our discussion for the question part D, where we need to find the equation of the locus of the moving point Q such that its distances from the points B and D are in the ratios 3:2. Okay, so this is the question part D, guys. Okay, so from here, what we're going to do is we're going to sketch the diagram for the question part D. So please wait. Okay, so this is the complete sketch of the diagram DB. Okay, as it mentioned here, Q is actually a moving point. Okay, let me write down the point Q over here. So as you can see here, the point Q is actually moving in the straight line in a line segment ratio of 2:3, guys. Okay, so from here, so let me label it in a black color. So this is your point Q. So we don't know actually the exact coordinate of point Q. So since it is a moving point, or also known as locus, so from here let us write down in terms of x, comma, y. Okay, so this is our locus. So the first step on what we need to do is we need to identify the locus. So in this case, our locus in this question is a straight line divided in a line segment ratio of 2:3. Okay, in respect of the ratio of BQ is to QD. So from here, let us continue our working. Okay, let me change the pen color. So from here, ratio of BQ is to QD is equals to 3:2. Okay, so we're going to convert this into the fraction form. So from here will be BQ divided with QD will be equals to 3/2. Okay, so now what we're going to do is we're going to cross multiply this. So from here you should get 2BQ is equals to 3QD. Okay, so this is our second step, guys, by getting the relationship of the locus. So from here 2BQ will be equals to 3QD. So this relationship is very important. So once you get this relationship, then only we can use this to calculate our equation of the locus Q. Okay, so let me box this. Okay, so from here let us calculate our locus. So from here 2BQ. Okay, so let us calculate our locus. Okay, in similar step for the distance. So from here, so 2, okay, you times with the square root. Okay, and then in the bracket, the step is actually similar to find the distance, guys. So from here, x minus 4 square plus with y minus 1 square, the bracket y minus 1 square equals to 3. Okay, let me put the square root line. Okay, so this 3 is representing the 3QD, guys. Okay, so from here, so the 3 you times with the square root, x minus 2 square plus with y minus 7 square. Okay, let me underline the square root line. Okay, for the next step, what you're going to do is we're going to square both sides. because we need to eliminate the square root. Okay, so we square both sides. So from here you get 4. Okay, and then let me draw a square bracket over here. So from here, x minus 4 square plus with y minus 1 square close bracket equals to 9. Okay, similar over here, the square bracket, x minus 2 square, okay, plus with y minus 7 square close bracket. Okay, so now what you're going to do is we're going to expand each bracket in the left side and the right side respectively. Okay, let's start to expand the bracket by beginning with the left hand side. So from here 4, okay, and then square bracket. So from here x square minus 8x plus with 16. Okay, this is based on the expansion of x minus 4 square, guys. Okay, and then plus with y minus 1 square. So you expand this, you should get y square minus 2y plus 1. Okay, close bracket. So from here equals to, okay, let me continue the working down here. Okay, so from here equals to 9 square bracket. Okay, x minus 2 square, you expand this, so from here you get x square minus 4x plus 4. Okay, and then plus with y minus 7 square, so you expand this bracket, so from here you get y square minus 14y plus with 49. Okay, close bracket. Okay, so now what you're going to do is we're going to expand the 4 and 9 respectively. Okay, let us begin with the left hand side. Okay, so we expand the 4, so from here we get 4x square minus 32x plus with 64. Okay, and then plus with 4y square. Okay, and then minus with 8y. Okay, and then you plus with 4. Okay, and then equals to, so now what you're going to do, we're going to expand the 9 into the bracket here. So from here 9x square minus 36y, I mean 36x, sorry guys, okay, should be 36x plus with 36. Okay, and then plus with 9y square minus with 126y. Okay, and then plus with 441. Okay, so from here, once you come up to this stage, the rest is all algebra, guys. Okay, so you need to arrange according to the highest power to the lowest power respectively. Okay, so in order for you to solve for this step, so what you do, you move all the variables from the left hand side to the right hand side over here. Okay, and then you start to solve them. Okay, you solve them, you should get your answer 5x square plus 5y square minus 4x minus 118y. Okay, and then plus with 409 is equals to 0. Okay, so this will be your final answer, guys. Okay, so let me underline the solution for the question part D. Okay, so that is all for the step-by-step working and the solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give your thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future, and not to forget to share this video. Any comments, feedbacks or questions, feel free to put in the comment section, guys. Thank you everyone for your support, and I'll see you in the next video.